Hello guys, in today's session we will see some basics of permutations and combinations. Let us begin with principles of OR and principle of AND. If I say I want to move from city A to city B, which is connected by 3 roads, that to move from A to B I could go through road 1 or road 2 or road 3. That there are 3 ways of doing the same thing. So you observe, it is the ways of doing same thing, so I'm counting them 1, 2, 3. So I'm basing principle of OR. Let us say I have to move from B to C and they are connected by 4 roads. Now I can go from B to C via road 1 or road 2 or road 3 or road 4. Again, I'm applying the principle of OR. I know that there are 4 ways or 4 possible options through which I can move from B to C. But if I say the task was to move from A to C, this can be done if I move from A to B and if I move from B to C. As you've already seen, there are 3 ways of moving from A to B. There are 4 ways of moving from B to C. And you observe there's an AND applied between them. So we multiply number of ways whenever there's an AND applied between the cases. Or we can say we apply the principle of AND when we have to do several things one after other or together. We apply a product of ways. So I can say there are 12 ways of moving from A to C. Let us apply same concept in a different scenario. If I say there is a selection to be made for 2 posts, one is for chairman, one is for vice president. And if I say the possible contenders are A, B, C and D. If I try to make selections for chairman, I have got options 1A, 2B, C3, D, 4. I have 4 options for this particular post. I am counting 1, 2, 3, 4 because there are options for the same post. Let us say someone has been given that post. Let us say D is that person. So D cannot be counted for the post of vice president now. How many options do I have for vice president now? A, B and C. I have total of 3 options. I needed a chairman and a vice president. Because there is an and between them, we multiply total number of ways and we say there are 12 ways in which a chairman and a vice president can be selected from A, B, C and D. Let us try these concepts on linear arrangement of things or people. If I say these are the 4 places where I am going to arrange A, B, C and D. First of all, can I say this is the place 1, this is the last place, this is the second last place and this is the second place from beginning. That means every place has got a definition of its own. And as you can see, these are distinct things to be arranged. If I try to fill the first place, I have got 4 contenders A, B, C, D. That means I have got 4 options with me. Let us say someone has been given that place. Let us say D is gone. Can I say second place has got 3 contenders? Let us say someone was given that place. D is gone. Third place has got 2 possible contenders. Let us say C is gone. Fourth place, only 1 option is left. Now if I say I have to fill in the first place and the second place and the third place and the fourth place, the number of ways should be multiplied, which is 24, or you can say this is 4 factorial. Or we say arranging n things in n places, we have n factorial ways. If you observe, the things that you are arranging must be distinct. The places in which you are arranging these things must be distinct, or they must be defined places. Let us try and apply this theory when we are arranging under certain restrictions. If I say A, B, C, D, E and F are to be arranged in a line, but the restrictions like A and B should always be together. In this case, what we do is we pair up those things or those people who are going to be together and we count it as one, and we count others separately. C is second, B is third, E is fourth, F is. So I have got 5 things that I need to arrange in a line. Because all of them are distinct, I can say there are 5 factorial ways of arranging them. But if you observe, A and B can be rearranged within that bracket. So A and B can be rearranged in 2 factorial ways. So total ways of arranging A, B, C, D, E, F, where A and B are always together, it's 5 factorial multiplied by 2 factorial. This 2 factorial is because A and B can be rearranged. If I say A, B, C should be together and D, E, F should be separate, this is counted as 1, 2, 3 and 4. There are 4 things to be arranged, out of which A, B, C can be rearranged among themselves in 3 factorial ways. So in this many ways A, B, C are together, and in this many ways total arrangements are done. What if I say A and B are never together? There are 2 methods to solve this. One is you find total number of ways of arranging A, B, C, D, E, F, which can be done in 6 ways, minus the number of ways in which they are together. But this method will not be easily applied if I say no 2 among A, B, C are together. Let us see how to solve this question with some other method. See, we are saying A or B or C cannot be together. So let us forget A, B, C for the time being. Let us arrange others on which there is no condition. If I say D, E, F are to be arranged, 3 things can be arranged in 3 places in 3 factorial ways. Let me pick a random arrangement. These 3 factorial arrangements already include this particular arrangement F, D, E. Now if you observe, I have got this place where someone could come, this place can be taken by someone, this place can be taken by someone, this place can be taken by someone. So there are 4 places open. So if I say A is to be arranged in the line now, A has got 4 options to go to. Let us say A takes this place. Now if I try to arrange B, you can see B has got 3 options available and none of these 3 options is adjacent to A. So A and B are never adjacent in this case. So B has got 3 options. Let us say B has taken this place. Now you observe C has got 2 options left here and another here, and none of these places is next to either A or B. So C has got 2 options or 2 places to go to. Now I needed to arrange A, B and C, and I need to arrange D, E, F. So let's say C here. The total number of ways is 4 into 3 into 2 for A, B, C and 3 factorial for D, E, F. That makes my answer as 24 multiplied by 3 factorial. In the next session, we will continue with linear arrangement under conditions And what if some of the alphabets are identical, or some of the things to be arranged in the line are identical? And afterwards we'll carry on with circular arrangement. Thanks for watching.